So I'm going to go through one more time how to run pdstrip real fast. So assuming you've downloaded the executable from SourceForge and extracted it to a directory called pdstrip on your desktop, what you're going to want to do is go Start, Run, then you're going to type cmd to bring up your command line. I'll go ahead and increase the font size. Now where you are is in your root directory. Your desktop's actually above this, so we need to change our directory to the desktop. So to do that, you'll type cd for change directory, then begin typing desktop, and you can either fully type it out or hit tab to autocomplete, then hit enter. Now you're on your desktop, so we need to go into the pdstrip directory. So one more time, cd to pdstrip. Now we're there. Anytime you want to see the contents of a directory you're in, you type in dir, and that gives you your directory. Okay, so looking at the pdstrip folder, you'll see that we've got the executable, and inside the examples subfolder, we've got the geometry and the actual input file that we need to send the executable. So the way we're going to do this is we're going to change directory into this examples folder where the data is, and then we're going to run the executable from the directory above it. Alright, so to do that, you type cd examples, going into the examples folder, and now we're going to run the executable in the parent folder by typing /pdstrip.exe. Again, you can auto complete that. And so the .. means directory before, slash is a separator between directories, and pdstrip.exe is just the executable. So now we're going to give it the pdstrip.input file. You can just type pd and hit tab to autocomplete that. And so what this is going to do is run the program and give it the input file from this directory. So we could hit enter to do that. It will take about 2 minutes to run probably on most of your computers, maybe longer depending on how old they are. So once you're done with that, you'll get multiple files in here. So you'll get 5 more files there. One of them will be section results. And so let's take a look at the section results file real fast. And so here's your output data. The first line is just a header line that you're going to want to ignore. The second one is the number of wave frequencies. And then it's going to be these 4-line data sets that are repeated 52 times. So to actually figure out what these are, we're going to have to look at the source code. So if you open up the Fortran 90 code, and you're going to want to do this with WordPad or something similar, because Notepad will probably not recognize the carriage returns and will give you a big garbled mess. So scroll down a little bit, it's not that far in, and you're looking for a frequency loop with some writes. Here it is right here. This is a for loop over all the frequencies, and then there are 5 writes, but the last one is not done because that if evaluates to false. So what we have is the first line writes out the wave frequency, then the number of wave and counter angles, and then those angles. For this program, that will the number of angles be 4, and then it will just give you 4 angles, which is sort of unimportant. Then the next line is kind of important. So it's omega **2, which means omega squared, times the added mass matrix. And so in this case, it's a complex added mass matrix, which means it's got both real and imaginary parts of a 3x3 matrix. Then it gives you the same thing in diffraction forces and the same thing in the Fruit-Krylov forces. Alright, so what we're going to need to do is from this output file, we're going to have to write some MATLAB code to bring it in. And I've gotten a little, oh no, well, I had so I'm going to have to start from scratch. So assuming you've used fopen to open the section results file, you're going to have to start inputting data to get down to where we want to get to. So the first thing you need to do is remove that single line, which is the header where it says example yacht1 test file March 2006. So to do that, I'm just going to assume that you've called your input file, which you've opened using fopen, finput. So you just use fgetLine, finput, and what this will do is get an entire line and remove that first line that we don't need. Next, you could get the number of frequencies, which is that 52. And to do this, you're going to want to use the fscanf command. And so fscanf takes two things. It takes a mask and a file handle, a mask, and then a number of inputs. And what the mask is it's basically the shape of the data. And so by shape I mean it's what it looks like in code. So here we have the number 52 after a single space, and to make fscanf read that in nicely, you just copy exactly what it is, and wherever the number is, you replace it by what type of number it is. So an integer, you put %d for. And what this will do is look for an integer that comes after a space, bring in one of these, and place it in num frequencies. Alright, so let's go to the next part, which is that wave frequency, and then the number of wave angles, and then the wave angles themselves. So an easy way to get fscanf right is just to paste it in. So you can just call this numbers, and this will put this in an array called numbers, or we'll call it input. Alright, so a really easy way to use fscanf is to simply paste in an example of the data you're trying to bring in, and then replace all the numbers you see with their number types. So before we had an integer value. Integer values are %d. I have no idea why. Floating point values, you just put in %f. So here we're replacing all of the values with just their equivalent data types. And notice we have 6 total values there, so again, you can tell it that you want to bring in 6 total values to make it happy. Really, you only wanted the frequency, so you could call this, say, omega is equal to input 1. Also, you could just ignore the rest of the line if you wanted to, but it's probably best to bring in all the lines and then just take out what you need. Alright, so now it gets a little bit more complex with the 3x3 complex added mass matrix here. And remember, this is multiplied by omega squared, so you'll want to later do something to get that omega squared out and get back to the added mass matrix itself. So we're going to use the same trick where we paste in some example data. Then we're just going to start in an fscanf. We'll call this input also. Alright, so what we've done is we just pasted in the sample data as a string, and we're going to leave everything that's not a number in this string and replace everything else with the data types. You'll notice that everything really just boils down to 2 floating point values in a comma separated pair. So if you count it, you'll see that we've got 9 real imaginary parts. And I'll just basically repeat that rather than one by one replace the numbers with their %f data types, which is what I would normally do. 1, 2, 3, 4, 5, 6, 7, 8, 9, for a total of 18 values coming in. Alright, so this is just put this in a 1 by n matrix, but really this is a 3 by 3 complex matrix, so you're going to want to use some sort of loop or nested loop to make this prettier. So what you could do is go through rows and columns and figure some way to put this into a 3 by 3 real and imaginary array, which will also have the frequency index, because remember you have 52 of these. I'll let you figure out how to do that. It's not really very difficult. Basically, you can look here and start thinking about it. If you want just the real parts, you want the first, the third, the fifth, the seventh, etc., etc. Or you could just figure out what those turn into with row and columns. if anyone's having trouble with that, just give me an email or something, and I'll give you a little bit more information on that. One thing you might want to do is predefine this array, because every now and then arrays don't really like to grow so much. They sort of like to exist, and if you tell it new dimensions, they'll get confused. So a lot of times what you want to do is say you have an array is going to be from zeros, and if I remember correctly, you just give it 3 by 3 by 52. Look up that function, make sure that's right, but do predefine your arrays. It actually speeds up your program execution too, which is always good. And hopefully that should get you guys started. Remember, most of the strips theory stuff is in P&A Volume 3, and get this homework started earlier. It takes you a little bit longer than you'd expect. Good luck, everyone.